I was staring at a tax form the other day, just a standard piece of government paperwork.
Oh, boy.
And I realized I was burning about, I don't know, 80% of my mental energy just trying to figure out the structure.
Right. Not the math.
Not the math at all. It
Yeah.
was like which box relates to which instruction. It was a format.
It's the cognitive load. You're spending all your processing power just decoding the syntax before you can even get to the actual data.
That is exactly it. And it got me thinking about the deep dive we have lined up for today. Because we are looking at a piece of source material that tackles this exact problem, but in the world of computer programming. It's all about how we communicate logic.
Right. We are diving into a blog post from qianmeng.org. It was published just recently, January 2026.
And it's part of a series.
A massive one. This is part 42 of his notes on Haskell programming.
Part 42. Wow. That is some serious commitment.
It is. The author, Eng, he calls himself an old software plumber, and I think that title is really key here.
Plumber.
Yeah. He's not a theorist sitting in some ivory tower dreaming up abstract math. He's a plumber. He cares about whether the pipes fit together and whether the water flows without, leaking.
And today, he is fixing a leak in how we read code. He's talking about a specific feature in the Haskell programming language called backticks.
Backticks. It sounds like a parasite, doesn't it?
It really does. Oh, I think I pick up some backticks in the woods.
Yeah, exactly.
But apparently, these little punctuation marks are the difference between code that looks like a robot's shopping list and code that reads, well, like a human sentence.
It's a fascinating look at linguistics, psychology, and really why the order of words matters just as much as the words themselves.
So let's set the scene here. Eng is working on a project.
Right.
He's building a command line tool called XS2book. He is deep in the plumbing, writing a test case.
Exactly. He's using a testing framework called HSpec. And the whole goal of HSpec is right there in the name, specification. You're trying to specify behavior.
You're describing what the program is supposed to do.
Precisely.
So he's writing a test to make sure the help message shows up correctly.
Yeah.
And he stumbles across lines 15 and 16. He sees something that, well, it stops him in his tracks.
He sees a line of code that reads, help MG should contain usage, XS2book.
Let me say it again, just for everyone listening, because code on audio can be tricky.
Good idea.
It says, help MG, then the function should contain, and then the string usage, XS2 ebook.
Now, to a non-programmer or just regular English speaker, that sounds perfectly normal.
Yeah. The help message should contain this text. It's just a sentence.
But that is not how computers usually talk.
No, it is not.
Not at all. In almost every programming language, and even in standard Haskell, the computer prefers what we call prefix notation.
Prefix, so the verb comes first.
It's the imperative mood. I mean, think of it like a drill sergeant. Eat your dinner, wash the car, calculate the total. The action always leads.
So if we were writing this test in that, standard computer-friendly way, how would it look?
You'd have to put the function, the verb, right at the very front. So it would look like should contain help MSG usage.
Should contain help message text.
Exactly. It's VSO order. Verb, subject, object.
Which feels a bit Yoda-ish. Contain it should.
It is. And while the computer loves it because it knows exactly what action to take immediately, for a human, it's actually kind of taxing.
How so?
You have to hold the verb in your working memory. Okay, I need to verify something contains something else, and then you have to stand forward to find what's doing the containing and what's being contained.
It creates a little momentary lag. You're buffering.
Precisely. It's a micro stutter in your brain. But what Eng discovered, and what was new to him, even at part 42 of his journey, is that Haskell lets you cheat.
Huh. How?
By taking that function, should contain, and just wrapping it in backticks, you can then drop it right in the middle.
You turn it into an infix operator.
You move from VSO to SVO, subject, verb, object, help MS should contain text.
It sounds like such a tiny change. I mean, we are literally just moving one word.
It seems small.
But the author argues this makes the code a domain-specific language, or DSL.
Right, and a DSL is when code stops looking like generic machine instructions and starts looking like the specific language of the problem you're solving.
And in this case, the problem is asserting a truth.
Exactly. When you write a test, you are telling a story about your program. This should happen, that should fail. And stories need a narrative flow.
And English stories flow left to right, subject to verb.
So by using backticks, you are aligning the code syntax with the linguistic pathways already hardwired in your brain. You aren't translating, you are just reading.
Okay, I buy that it looks prettier. And I definitely buy that it reads nicer. But does it actually help with complexity?
Yeah.
Because Aang calls himself a plumber, right? Not a poet. He cares about function. Is this just aesthetic sugar, or is there a real utility here?
Oh, it absolutely helps with utility. And to prove it, Aang uses a simple math example in the post, the add function.
Yeah, let's walk through this. Add. Simple addition.
In the standard prefix world where the verb must come first, adding 2 numbers is easy. Add 1, 2. The computer gives you 3.
Fine. That's easy enough to read.
But what if you want to add 3 numbers? 1, 2, and 3.
Well, in my head, I just say 1 + 2 + 3.
Right, but the function add is dumb. It only knows how to hold 2 things at a time.
Yeah.
So if you put the verb first, you have to nest them. You have to say, add the result of adding 1 and 2 to 3.
Oh, I see where this is going. It's going to be add 1, 2, 3.
Yep. You've got parentheses inside of parentheses.
That is ugly.
It's not just ugly, it's noise. Aang calls it parenthesis noise.
I like that term.
Every time you open a bracket, you are opening a mental thread that you have to close later.
It's like when someone interrupts a story with a side story, and you have to remember where the original story left off.
Perfect analogy.
Huh.
That is exactly what the stack in your brain is doing. Now look at the backtick version. You turn add into an infix operator.
So I can just write 1 add, 2 add, 3?
Linear, sequential, no brackets, no mental stack.
That is objectively cleaner. It basically turns the code into an equation you'd see on a chalkboard.
And that is the power the title of the post refers to. It isn't about the backticks themselves. It's about removing the cognitive load of parsing the structure so you can focus on the logic.
Okay, hold on, though. If this is so great, if it removes the noise, aligns with English, and makes the plumber's life easier, why isn't the whole language written this way? Why does prefix notation even exist anymore? Why don't we just backtick everything?
That is the question Aang poses. Why do we not use them for every function? And the answer reveals something really deep about how Haskell and really functional programming in general works.
There's a catch. Of course there is.
It's a trade-off. Sometimes you don't want a sentence.
You don't.
No. Sometimes you want a machine.
Okay, explain that.
It comes down to a concept called partial application, or as the math nerds call it, currying.
Currying. Right? Aang mentions he covered this way back in part 26.
He did. So here's the simplified version. In Haskell, if you have a function that needs 2 ingredients, but you only give it 1, it doesn't crash.
What does it do?
It just sits there holding that 1 ingredient, and it transforms itself into a new function that is just waiting for the second one.
Okay, that's a bit abstract. Can we get a concrete example?
Sure. Let's look at the map example from the source. Imagine you have a list of numbers, 1, 2, and 3.
Okay.
And you want to add 5 to all of them.
So I'll turn 1, 2, 3 into 6, 7, 8.
Exactly. In the standard verb first prefix notation, this is beautiful. You write map, then you write add 5, then your lists.
See what happened there? Add normally needs 2 numbers. You only gave it 1.
So add 5 becomes a temporary little factory. A plus 5-inator.
Plus 5-inator. I love that. Yes.
I like that.
And you hand that little factory to map, and map just runs it over the entire list. It's elegant. It treats the function add 5 as an object.
Oh,
Now.
I see. So in this case, we aren't telling a story about adding. We are building a tool that adds. Exactly. Now, try to do that with backticks.
Map 5 add.
You technically can do it. It's called a section.
Yeah.
But it just looks weird, doesn't it? It feels disjointed. You've got a verb hanging off the edge of a number with a backtick. It breaks the visual flow.
So the English sentence structure actually gets in the way here.
It does, because here you aren't saying 5 should add to X. You're passing the concept of addition.
This is a really subtle distinction.
It is. But it's the difference between a script and a pipeline. When you write a test, case like should contain, you are writing a script, a narrative. This should happen.
Okay.
When you are processing data-like with map, you are building a pipeline. Take data, put it in a box, move to next box.
And pipelines benefit from the prefix notation. Do this, then do that.
Exactly. So Aang's conclusion isn't backticks are better, it's backticks are a tool. You use them when you need readability and flow. You use prefix when you need composition and machinery.
I'm going to circle back to the author Aang for a minute. Because what you just described, knowing when to build a pipeline versus when to tell a story, that feels very much like that old software plumber mindset we talked about at the start.
It really is. It's pragmatic.
I was looking through the sidebar on his site. It is not just code. He has notes on everything.
It's a wild list. Notes on gardening, notes on fish keeping, notes on the European olive.
I saw betta spawn logs.
Yes. But if you think about it, a fish tank is a system. A garden is a system.
So inputs, outputs, maintenance.
Exactly. And if you plant your olive tree in the wrong spot, if you get the structure wrong, it doesn't matter how much you water it, it won't thrive.
Just like if you use the wrong syntax. The code might work, the computer might execute it,
Yeah.
but it won't be readable. It won't be maintainable.
Right. And Aang admits in this post that even after 42 parts, this specific syntax was quite new to me. I love that humility.
It validates the idea that you don't have to know everything to be an expert. You just have to be curious enough to notice when something looks different.
And willing to stop and ask why. He didn't just copy-paste the code. He stopped at line 15 and asked, why are there backticks here? What is this doing to the logic?
He pruned the syntax to see the structure underneath.
He did. And by writing it down, by explaining it to us in part 42, he solidified that knowledge. That's the plumber approach. You learn how the pipes fit by taking them apart.
So as we wrap up this deep dive, what is the big takeaway for the listener? I mean, maybe they don't write Haskell, maybe they don't code at all. Why should they care about backticks and infix operators?
I think it comes back to that idea of empathy.
Empathy. That's a big word for a punctuation mark.
Empathy for the reader. Whether you're writing code or an email to your boss or instructions for a house sitter, you have a choice. You can write in a way that is easy for you to output. Just a list of commands. VSO, do this, feed cat, lock door.
Efficient.
Efficient for the writer, but it's often harder for the reader to parse. Or you can take a moment to use the backticks of natural language. You can structure it as a story. SVO. The cat needs to be fed at 5 p.m.
You establish the subject before you demand the action.
You lower the cognitive load. You remove the parenthesis noise from your communication.
That is a powerful idea. Code isn't just instructions for machines. It's communication between humans.
The machine doesn't care about backticks. The compiler strips them all out anyway. It turns it all into binary eventually. The backticks are there entirely for the human being who has to read that code 6 months from now.
And that human being might be you?
Exactly. Be kind to your future self. Use backticks.
I love that. So here is a thought to leave you with today. We talked about how a simple change in word order, moving the verb to the middle, can change noise into insight.
From a command to a sentence.
Right. So think about the last time you made a mistake following instructions. A tax form, a recipe, a confusing road sign. Was it actually user error? Or was it a translation error? Did the writer give you the verb before your brain was even ready for the subject?
That is something I'm going to be looking for everywhere now.
Me too. Aang, the old software plumber. Thanks for the lesson in readability. And to you, listening, thanks for diving deep with us.
See you next time.